The wind arrives first. It does not whisper, cuts. Across frozen plains, barren tundra, high mountains, and empty deserts, the ancient world offers no mercy. Temperatures plunge below -30 degrees Celsius. Water freezes. Skin cracks. Breath becomes visible proof of life in a landscape designed to erase it. Here, survival is not instinct alone. It is engineering. Before tools, before cities, before language is fully formed, the human body stands fragile against physics. A resting human generates roughly 100 watts of heat, barely enough to warm a small light bulb. Yet, in an open winter storm, heat escapes 25 times faster than it can be produced. Wind strips warmth through convection. Frozen ground absorbs it through conduction. Radiation bleeds energy into the night sky. Within hours, exposed flesh turns numb. Within days, death is certain. Cold is not merely temperature. It is energy loss. Survival begins with slowing that loss. Ancient humans learn quickly. To live, they must control heat. The first shelters are not homes. They are shields. A rock overhang blocks wind. A fallen tree creates a barrier. Snow itself becomes an ally. Fresh snow contains up to 90% trapped air, making it an effective insulator. Inside a snow shelter, even when outside temperatures drop below -40 degrees Celsius, interior air can remain near -5 degrees Celsius. Primitive yet life-saving. The Earth offers another secret: thermal stability. Below roughly 1 meter underground, soil temperature remains nearly constant year-round, often between 5 degrees Celsius and 12 degrees Celsius depending on region. Ancient humans begin to dig. Not deep caverns, but shallow depressions. Pits lined with stone. Earth-sheltered dwellings. By lowering themselves into the ground, they step out of the wind, out of rapid heat exchange, into a slow and controlled thermal world. These early structures follow logic, not luck. Openings face away from prevailing winds. Entrances are lowered, forcing cold air to settle below the living space while warmer air remains above. Walls are thick, sometimes over half a meter, reducing thermal conductivity. Every design choice answers a single question: how to keep heat from escaping. In frozen tundra, bones of mammoths and whales form frames for huts, covered with hides and packed snow. In deserts, where heat replaces cold as the enemy, the same principle applies in reverse. Thick mud walls absorb daytime heat and release it slowly at night, stabilizing interior temperatures. Underground chambers remain cool when surface air exceeds 45 degrees Celsius. Whether freezing or burning, survival means controlling thermal flow. But shelter is not only about temperature. It is protection from predators, storms, and exhaustion. Exposure drains calories. A human in extreme cold may burn 4,000 to 6,000 calories per day just to maintain body heat. Without shelter, energy becomes impossible to sustain. The body weakens. Movement slows. Hunting fails. Shelter is not comfort. It is the foundation of energy economics. Inside these early structures, darkness dominates. Smoke stains ceilings. Moisture freezes on walls. Yet within this small protected space, something revolutionary begins. Humans start shaping environments rather than merely enduring them. Construction evolves. Stone bases prevent ground moisture from seeping upward. Layers of grass, moss, and fur create composite insulation systems. Snow is packed strategically to block air infiltration. Roof angles are adjusted to shed wind. Even without mathematics, early humans understand structural load. Snow accumulation can collapse weak roofs, so supports are reinforced with thicker beams or curved designs that distribute weight. The dwelling becomes a machine, not mechanical but thermal. Every wall stores energy. Every opening regulates airflow. Every surface participates in the battle against entropy. Water presents another challenge. Liquid water is life, yet in freezing climates it becomes scarce. Snow must be melted, requiring heat, which requires fuel, which requires labor. The location of shelter often depends on proximity to both fuel and water sources. Too far, and energy is wasted retrieving them. Too close to open water, and cold winds intensify. Settlement becomes a balance of thermodynamics and geography. Time passes. Knowledge accumulates. Shelters become semi-permanent. Clusters of dwellings appear, positioned to reduce collective wind exposure. Snow walls are built as windbreaks. Entrances are tunneled. Roof smoke holes double as primitive ventilation systems. Even before the discovery of advanced tools, architecture emerges from necessity. The cold remains relentless, but humans are no longer passive. They begin to understand a fundamental principle. Survival is not about resisting nature, it is about redirecting its forces. Fire waits beyond the threshold. The next transformation will not merely protect life. It will sustain it. Night falls. Darkness deepens. Inside the shelter, a glow appears, the first controlled fire. Fire is not just warmth. It is chemistry, energy conversion, and survival distilled into flame. 1 kilogram of dry wood releases roughly 15 megajoules of energy when burned. For ancient humans, this is stored sunlight, captured by trees and released on demand. Fire becomes the heart of the dwelling, the central engine of survival. Yet fire is dangerous. Too little oxygen and it dies. Too much smoke and lungs fail. Ancient humans begin engineering combustion. Hearths are placed centrally, surrounded by stone to retain heat and prevent ground ignition. Elevated platforms reduce heat loss into soil. Reflective stones radiate warmth back into the room. Slowly, the open flame becomes a controlled thermal system. Ventilation is critical. Without it, carbon monoxide, odorless and lethal, accumulates. Early dwellings incorporate smoke holes in roofs and angled air channels near the floor. Warm air rises, carrying smoke upward, while cooler oxygen enters below, feeding combustion. This natural convection system requires no machinery, yet maintains breathable air. Trial and error teach these invisible laws of fluid dynamics. Heat is precious. Nothing is wasted. Stones placed near the fire absorb energy and release it slowly through the night, functioning as primitive thermal batteries. Animal hides are positioned to block drafts. Sleeping platforms are elevated above the coldest air layer. Even the positioning of bodies around the fire reflects an understanding of heat distribution. Animals become part of the system. In some cultures, livestock share interior space during winter. A single large animal can produce 500 to 1,000 watts of heat, equivalent to multiple humans combined. Their presence raises interior temperature, reduces fuel consumption, and stabilizes humidity. Survival becomes symbiotic engineering. Fuel management defines daily life. Wood must be gathered, dried, and protected from snow. In treeless tundra, driftwood, bone, and animal fat serve as substitutes. A winter settlement may require several tons of fuel to survive the season. This demands planning, cutting wood months before winter, storing it under cover, rationing burn rates. Fire is life, but it is also responsibility.
Cooking evolves alongside heating. Raw food requires more metabolic energy to digest. Cooking breaks down proteins and starches, increasing caloric efficiency by up to 30%. Boiling water kills pathogens. Drying meat preserves it for months. Food systems become integrated into survival engineering. Hunting, preservation, storage, and rationing form a continuous cycle. Clothing is another engineered system. Fur traps air, the same principle as insulated walls. Multiple layers create thermal gradients, reducing heat flow outward. Moisture control becomes critical. Wet clothing increases heat loss dramatically through evaporation. Humans learn to dry garments near the fire, rotate layers, and use animal fat as water-resistant coating. Clothing is not fashion. It is portable shelter. Daily routines follow strict efficiency. Morning begins with reigniting embers preserved overnight under ash. Fuel is rationed. Water is melted. Food is prepared. Tools are repaired. Every action conserves energy because in extreme environments, wasted effort equals reduced survival probability. Light extends productivity. Firelight allows work during long polar nights. Shadows flicker across walls, transforming small shelters into living systems of motion and warmth. Emotional comfort becomes intertwined with thermal stability. A dying fire is not just cold, it is fear. Over time, systems grow more sophisticated. Some cultures design multi-room shelters separating sleeping, storage, and fire areas. Others build underground tunnels connecting dwellings, minimizing exposure to storms. Insulation materials improve: moss, peat, layered skins. Airflow is fine-tuned. Smoke becomes less suffocating. Interiors grow warmer, sometimes reaching 15 degrees Celsius even when outside temperatures remain far below freezing. Efficiency is everything. A well-designed shelter can reduce fuel consumption by half compared to an exposed fire. This difference determines whether a community survives winter or starves before spring. Engineering becomes invisible but essential. But survival is more than warmth and food. Inside these shelters, humans begin shaping routines, relationships, and meaning. The environment is still hostile, but life inside grows structured. The machine of survival now includes the human mind. Winter continues. Outside, the world remains silent and frozen. Inside, fire burns steadily, proof that humans have not conquered nature, but learned to negotiate with it. Winter stretches endlessly. Days blur into darkness. Isolation presses inward like the cold itself. Physical survival alone is no longer enough. Now begins the challenge of psychological endurance. Inside confined shelters, small groups share limited space for months. Social balance becomes critical. Conflict wastes energy and threatens unity. Ancient communities develop unwritten rules: shared labor, shared food, shared responsibility. Cooperation becomes a survival technology. Storytelling emerges as warmth for the mind. Around the fire, elders recount hunts, migrations, and lessons learned. Memory becomes a library. Knowledge is preserved not in books, but in voices. These stories encode engineering wisdom: where to build, how to prepare, when to move. Oral tradition becomes the operating system of survival. Spiritual belief also takes root. Fire becomes sacred. The earth becomes protective. The sky becomes a force to respect. Rituals offer psychological stability, reducing fear and reinforcing unity. When nature feels uncontrollable, meaning becomes a form of resilience. Children learn through observation. They watch shelter repairs, fuel preparation, clothing construction. Skills transfer silently, generation by generation. This continuity ensures that survival engineering evolves rather than resets. Each winter adds knowledge. Each failure teaches improvement. Preparation for spring begins long before thaw. Food stores are monitored. Tools are repaired. Hunting routes are planned. Survival is not reactive, it is anticipatory. The cycle of seasons becomes predictable, and with predictability comes strategy. Isolation ends. Ice melts. Rivers flow again. Communities emerge from shelters not as victims, but as engineers of endurance. The knowledge forged in extreme environments shapes future civilizations. Architecture, agriculture, thermal design, and energy efficiency all trace roots back to these early experiments in survival. Modern humans live in climate-controlled buildings, yet the same physics applies. Insulation, ventilation, energy storage, and thermal regulation remain fundamental principles. Ancient shelters were not primitive, they were optimized solutions under severe constraints. The legacy of these early engineers is not written in stone monuments, but in invisible understanding. They learned that survival is a system: heat, energy, cooperation, knowledge, and belief working together. As the fire fades and the long winter passes, one truth remains: humanity did not survive because nature became gentle. Humanity survived because it learned to design, adapt, and endure.